Been with us from the beginning. We started out small um, at Hopkins in Baltimore with about 12 or 15 attendees. We expect when the day is over, about 30, 35 writers will have come through to hear what's being said today. As you know, and those of you who have been here before know, one major reason for doing the boot camp, the major reason, is to allow you to become acquainted with an area in which you may be interested, and to provide, in as short as possible time, some exposure to the relationship between basic research and the applications of research in a particular field. A secondary benefit of the experience, I think, is that you'll have an opportunity to meet a number of scientists with whom you'll be able to communicate in future. You can rely on the scientists here and their colleagues at Hopkins to provide you with information as you need it. You're always welcome to visit our facilities at Johns Hopkins to request an opportunity to see what's going on firsthand. The weather is not cooperating with us today. Whatever it is, this must be day 120 of the sequester, maybe longer than that. So we're still doing science, but we're doing science under not just the sword of Damocles. The sword is actually being used right now. So these are interesting times. And, I've had the opportunity to speak about the interesting times on a couple of national news outlets since December. One of them, CBS, and the other, unfortunately, or fortunately, begins with F and ends in X. But they both treated the subject deftly, fairly, and I think with an intent to have an impact. So today we're going to focus on regenerative medicine. There's probably no field in clinical medicine today that's moving as quickly and with so much immediate promise as regenerative medicine. It's something that I would never have dreamed of 5 years ago. Regenerative medicine also gives us the opportunity to talk about the deep, the importance of fundamental research to clinical application. Because I think in every instance you're going to hear today, the roots of that application are in basic discovery, without which nothing would have happened. So I hope that becomes clear, and if it's not clear from the talks, it'll become clear from your conversations with the speakers at lunchtime and at the breaks. So our first talk is going to be from Erica Matunis, who's going to be momentarily professor of cell biology at Johns Hopkins. She is a leader in stem cell biology, particularly the stem cell biology that underlies the replenishment and generation of germ cells. She'll be followed by Jun Liu, who is professor in the pharmacology department at Johns Hopkins, who will be talking about the application of a particular class of drugs, or classes of drugs that affect angiogenesis on regeneration. Mark Donowitz is director of our Center for Epithelial Disorders and is director of research in the GI division at Hopkins. Mark is a superb basic scientist and clinician, so he's one of those people at Hopkins who does both things very, very well. Professor of medicine, and he's going to be talking about how we can try to engineer tissues in a dish. And his topic is going to be the mimicking of small intestinal function in culture. Warren Grayson has recently joined the Johns Hopkins faculty in biomedical engineering and is one of a superb group of young material scientists who are engineering biological materials functionally in vitro. And Warren will be talking about his efforts to build bone outside of the body. Guoli Ming, who just this past year won the Young Investigators Award of the Society of Neuroscience, is professor of neurology and is one of my colleagues in the Institute for Cell Engineering at Johns Hopkins. Guo Li will be talking about her work on stem cells in the central nervous system. We'll remain in the central nervous system for the next talk. Ron Schnarr, who's professor of pharmacology and of neuroscience, will be talking about manipulation of a class of biological molecules and how they promote repair in the spinal cord. Obviously an extremely important problem, and one in which there's been a lot of progress the last couple of years. Jeff Bolte is another one of my colleagues in the Institute for Cell Engineering, a professor of radiology. You can't really study what happens to a stem cell when you've transplanted that cell unless you can track that cell. And Jeff is one of the national leaders in understanding and inventing ways in which we can track stem cells and assess their function after they've been introduced into an organism. So he does a lot of engineering style stuff and imaging to do that. Gary Gerstenblith, who's in the Department of Medicine, will talk about a topic that I know many of you have heard of, which is the use of stem cell implants to repair myocardial damage. So if you could actually replace dead heart tissue with cardiomyocytes that are derived from a stem cell, that could give you sufficient increase in cardiac function to avoid heart failure. And then we're going to move to hematology with Rob Brodsky, who's director of our hematology division at Hopkins. Who'll be talking about what really was the initial kind of stem cell therapy. So we don't think about this often, but hematopoietic cell transplantation, blood cell transplantation, was the initial form of stem cell therapy. And Rob is going to talk about the use of transplantation for the treatment of sickle cell anemia. Gerald Brandauer is one of my colleagues in plastic surgery who had what appears to be a spectacular success recently as he participated in the team that transplanted a pair of limbs to one of our servicemen who had lost both limbs when an RPG exploded. So he'll talk about how we get around transplantation rejection in those cases, and it's very imaginative work. And that's what we're going to be seeing today.